Okay, welcome everybody. Thanks very much for joining our water wastewater webinar. We're very excited to put it on. I want to do a little housekeeping and I want to make sure that you all know you can put a question in the Q&A box and we'll get to that at the end. If you just put it in there during our session, we'll definitely do that. We encourage you to post questions there. And also we wanted to let you know we will share the presentation with you along with a copy of the recording after. So with that, let's go ahead and get started. I want to introduce our panelists that we have. We have Vishal, he's our product manager, and he has 20 years experience in SCADA and telemetry, 3 years at ProSoft, and he focuses on remote access and protocols. And then Vic is our regional manager. He has 20 years experience in automation and motion control. He's been with us at ProSoft for 2 years, and he specializes in modernization, wireless, remote access, and protocols. So you're in good hands today, and I want to go ahead and pass it off to Vishal to get us started.
Thank you very much, Julianne. Firstly, thank you all for your time this morning. We certainly appreciate it. So just a reminder, please make sure that you post your questions on the Q&A window rather than on the chat. And that allows us to monitor those questions. And as Julie said, we will get through to them at the end. So with that said, what's today's session is all about? We know that in the water and wastewater space, there are some fairly unique challenges that's very specific to those applications. And those challenges are centered around the connectivity and the modernization of assets, primarily because of how old those infrastructure services are. And today we're going to be looking at how the solutions from ProSoft can help you achieve this greater reliability through this connectivity and modernization, and to ensure that you can make data-driven decisions that ultimately will impact your productivity and efficiency positively. Now, the first part, so this webinar is in 2 parts. So the first one is to look at connectivity, and the second part, which will be headed by my colleague Vic Perangelo, is going to be looking at modernization. And this first section is about connectivity challenges and importance. Let's look at what are the main connectivity challenges, and you can boil them down to sort of these half a dozen main bullet points. The challenges that, the connectivity challenges facing the water wastewater industry today is centered around the fact that all of the assets are geographically dispersed. And if you take a water system or a wastewater system, you don't have a complete system for every dwelling in an area or every street. It is geographically dispersed over several miles, sometimes hundreds. So connectivity to all of those different assets to ensure that you've got a true picture of what's happening in the system and you can react is a challenge. And then you have different types of assets as well. You've got things like assets that may be, pump station that may be down a valley versus a water tower that's sort of got more a higher ground. You've got treatment plants. So you've got all of these different types of assets that tend to have different processes, tend to have different requirements in terms of how much they need to communicate, what data they need to communicate. So that's another challenge that you've got to take into account when you're looking at connectivity in a water wastewater system. Then you've got different types of data. We know that water is a critical infrastructure service. It's been around for some time, and some of these assets are getting to the point where they're getting old. But it also means because they've been around, they've got all of these different types of systems, protocols around that have sort of grown over a period of time. So you've got this challenge of trying to connect to all of these different types and bringing all of the data back to one common top end. That then leads to where you've got old devices, you've got new devices. And again, the challenge is to make sure that you're able to connect to all of them, because every piece of data is very, very important. So, you want to make sure that you're getting as much data possible that gives you that overall view of how the system is performing, with the view of then improving your efficiency and productivity. security. This is ongoing. We only have to look at some of the more recent instances. So this is something that is continuous, and therefore the requirements are changing. More in fact that they're increasing, and that's another challenge that you've got to keep in mind when you're looking at connectivity to all of these remote sites. And then finally, it's a continuous service, right? I mean, we're also used to, when we turn on the tap, that we get water, when we flush a toilet, that it works correctly. Because it is continuous, you also want to make sure that your connectivity is continuous and reliable, so you can ensure that the level of service expected by the today's customers, that those targets and those key KPIs are met. Now, we looked at what the challenges are. If you take that challenge and say, okay, now we know why connectivity is important, there's almost a direct correlation, right? So connectivity is important because you want to have real-time access to information. You want to have that information flow between OT and IT, or the enterprise division, because that allows you to make better business decisions on ensuring that you can meet those key performance KPIs about continuity, about ensuring that customers have got a continuous and a reliable service. That connectivity is important because you need to be able to bring back data from all of your remote sites to ensure that any type of maintenance can be done correctly. So you really want to do more predictive maintenance rather than reactive maintenance. And for that, you need data, and for data, you need connectivity. If you've got good connectivity, you've got reliable connectivity, you're also able to reduce your mean time to repair, which again, that affects your downtime, which then affects service levels. So these are kind of are all interlinked to these things between the challenges and the why the connectivity is important in terms of ensuring that this service is reliable as far as the customers are concerned. So if you look at the type of assets that need connectivity in a water wastewater system, they can be categorized into three main sections. Firstly, you've got the treatment plants, whether it's a water or a wastewater treatment plant. That's more geographically, in a smaller area, in a confined area. So you need a different connectivity requirement there. And then you've got pumping stations, and then you've got storage, whether it's a wet well, that is connecting to the wastewater side, and then passing that on down the system till the way it gets to the treatment plant, or the other way around, where you've got water storage tanks that have got water and then is dispersed as required through the pumping stations and so forth. So you kind of got these three primary type of assets, and there's lots of others, there's flow meter stations and things, but these are the three main types that require connectivity within a water or a wastewater system. So let's look at the first type of connectivity. This is connecting to get data from all of these different systems. As I said, water is continuous, it's critical infrastructure. Many of these assets have been in operation for several protocols. That means several years, I should say, sorry. That means you've got all of these different types of industrial languages or protocols at all of these different sites that need connection. So you could have a common, it is not feasible to have a top end to monitor all of your systems that, let's say, just only work on Ethernet IP, and another one that only works on Profibus. That's not economically possible. You're not going to have an entire overview, a clean overview of the entire system. So the ability to connect these disparate protocols and then have this information available in the single common top end is very, very important. With ProSoft, we support over 40 different protocols, giving approximately about 100 different combinations, whether it's Ethernet IP to Modbus or Ethernet to Siemens and vice versa, or even communicating with some of the older systems like DeviceNet and ControlNet. We can certainly help you there to connect to these systems and ensure that you can bring the data back. We also support many of the newer protocols like OPC UA and MQTT as well. Again, this with the newer protocols, you can actually get sort of what I call as a plant floor information directly onto the business enterprise. The next type of connectivity you're going to need is within the plant. Remember, I said that these are typically geographically in a smaller area. A treatment plant has got many parts associated to it, filtration and sedimentation and chlorination. They're all individual processes. They're all individual sections within the entire plant. But because they're in a smaller area, you don't need um, you don't need to use sort of cellular communications or even wired, which can be pretty expensive if you're trying to connect all the different parts to the plant. You're looking for something that's reliable, with something that's effective and is always on. Industrial 802.11 is a great way to go, where you can connect these different parts of the plant and again bring all of that information back to a common top end. And then the last type of connectivity that you have to that you need for a water wastewater system, and in my opinion, the most important, is remote connectivity. And here, because you've got assets that are geographically dispersed over a wide area, you need sort of this reliable and increasingly very secure connectivity to all of these sites in real time to get the information, again, with the aim being that it gives you a clear picture of what's happening, that then allows you to make the right decisions, allows you to ensure that the entire system is operating efficiently and effectively. A simple way to do that, and really the future, remote communications again has been around since Middle Earth, right? I mean, if everybody remembers the scene in Lord of the Rings where they're lighting fires at the top of mountaintops for communication, that remote communications has been around forever. But if you fast forward to today, the most reliable and the most secure way to do it is really using a readily available infrastructure that's already out there, and that's cellular communications. Just over the last decade or so, the amount of cellular coverage exceeds the air we breathe. I mean, that's how ubiquitous and how reliable it has become. And it's only getting better. If you just see the if you see the evolution of the technologies in the cellular space, it is pretty rapid and pretty significant. And that bodes well for utilities like us, because we want to be able to use this infrastructure to connect to all of these very remote sites quickly, easily, and bring all of that information back again that can then help you give you a much better picture of what the system is happening. The persistent data network, or the PDN solution, is this always-on cloud-based infrastructure network that has got continuous security. We know that, like, as I said before, security is sort of not a one-step thing. Attacks are persistent, which means security needs to be continuous. And that's what PDN can do for you. And there are some pretty significant advantages of this always-on remote communications network. Apart from the security, one of the biggest advantages is that it is completely agnostic in terms of the carrier. Even just in the example up there, this is a demo network that ProSoft has set up to test the system. In many ways, you've got sites spread globally on different carriers. So, Verizon versus Vodafone versus Telstra in Australia. And these sites are all able to communicate to each other. And it's a pretty huge advantage if you think about it. Even in the US, let's say, for example, you take the city of Denver, where you might have an area where AT&T is stronger versus, let's say, another part of the city where Verizon is stronger. And you don't want to have two different networks coming to two different top ends, and then you're trying to merge all of the data. It really is very inefficient. What the PDN can do for you is allow you to put remote sites from different networks onto a single network, and then get all of that data to a common top end where you can then monitor that information. Okay. PDN is extremely secure. We spoke about how important it is. The security for PDN is based on defense in depth, which is basically a multi-layered approach to security. And with that, what we look at is everything from the device itself all the way through the platform where you're accessing it, making sure that's integrated with IT so they can monitor the system, they can know what's happening, but then also looking at the entire mode where you've got all the way from the device through to the actual data itself. Once you've got the connectivity, the next thing that's really important is to make sure that your data is reliable. And you can achieve data reliability using DNP3 protocol. DNP3 stands for Distributed Network Protocol. And we could do a complete training session on this by itself. We are not going to have time to cover all of it today. If you do need more information or you want to have a better understanding, please get in touch with your local ProSoft manager or your distributor, and we can certainly help you there. But basically, at a very, very high level, what DNP3 allows you to do is to make sure that there's no holes in your data, because it allows you to classify your data and it logs the data, meaning it stores the occurrence of an event, whether it is good or bad, whether there's an alarm or a standard event, with a timestamp that's local to the site. And the advantage of all of that is you can bring back information in groups or as required, with the most critical being always available to ensure, again, you've got a complete and a current view of the system, but then you're not missing out on anything, let's say, that happened between communications, for example, where a level might have changed or a tank might have gone faulty on and off. You can capture all of that. So really with DNP3, you can be ensured that there's no holes in your data. So with that, I know I've spoken a lot, and Vic, I apologize in advance, I've gone over to you to talk about how modernization can help improve connectivity as well.
Thanks, Vishal. So good morning, everyone, or good afternoon. I'm Vic Perangelo. I'm going to talk a bit about modernization as it pertains to water and wastewater infrastructure. Next slide, please. I promise this is the only slide where I'm going to make you do any reading. Besides the obvious things like reducing downtime or risk mitigation, as Vishal mentioned, there are some things that just have a zero tolerance policy for failure when it comes to water, right? I mean, you might lose your cable TV or your power to your house or even your internet, but can you imagine turning on the kitchen faucet or getting in the shower and it's like, sorry, no water today? Yeah, I was watching the news early this week on Monday, and they were talking about the water problems that they were having in Missouri. They interviewed a local town official, and he actually said this. He said, our water municipality consists of two old guys who used to be plumbers. So I thought this cartoon was sort of apropos. So I'll ask, what exactly is driving the need for modernization in water and wastewater? Next slide, please. So modernization drivers can be reactive or proactive. The reactive driver is typically obsolescence, right? Utilities react to things like getting parts and skills obsolescence, or due to funding or lack thereof, the life of existing assets may need to be extended. Can they squeeze every last year out of that service life? Can they find the parts and, like that cartoon, can they find the people, that actually understand how to run it? Then there's the proactive approach, like, hey, there's new technology, there's new products with new features, we can get more data, we can run with less manpower, maybe get more alarms, it'll be safer, more secure, whatever. Next slide, please. So what are we talking about here? I'm sure you recognize some of these, right? PLC 5s and SLICs, old drives, FlexIO with the obsolete 1794 ASB adapters. To keep some of this stuff alive, it's gotten to the point where you have to rely on eBay for sourcing parts. This is where a phased migration can be considered, as a possible alternative to a rip and replace modernization. Next slide, please. What exactly is phased migration? This potential avenue of modernizing all the old water automation stuff that I'm going to describe here is called phased migration. Unlike a rip and replace, where you tear out and replace everything, a phased migration allows you to modernize in stages. The biggest risk factor in any migration is usually the PLC and troubleshooting the new code. Or, when you have a bunch of end devices, like shown here on the right, panel views, IO, old 1336 drives. This adds to the challenge. In a perfect world, you would modernize all the end devices first, but the new modules out there don't support Bluehost. So here's a way that you can mitigate the risks. Next slide, please. First of all, you can leave the PLC alone, and you don't even have to touch the code. You can add a modernization gateway configured as an adapter that takes you from Data Highway Plus or Remote IO to Ethernet IP. On the top row there, you see that a 1336 drive was replaced with an Ethernet-based PowerFlex drive. In the middle, the PanelView Classic was replaced with an Ethernet-based PanelView. And then on the bottom, the obsolete 1794 ASB adapter on the Flex is replaced with the 1794 AENT Ethernet adapter. That is phased migration. We changed out the peripherals, but we left the PLC untouched. So you could say, well, that's cool, but what about the other way around? What if you want to change the PLC, but leave everything else alone? You can do that too. Next slide, please. So what I'm going to show you here is like a textbook phase migration. Here you can see a slick with a bunch of remote IO drops. The important thing to note here is this. These IO racks are on a remote IO network, meaning there's going to be a lot of engineering and labor involved if you want to do this all at once. Remember where earlier we mentioned, risk and funding, right? Both apply here. A phased approach here would allow you to begin by replacing only the PLC using a gateway configured as a scanner. Slide. Next slide, please, Vishal. The field IO still works. Now you have Ethernet IP in the system and a current platform that can be connected elsewhere. And when time and money and other resources permit, next slide, please. One by one, you can migrate the individual IO racks until all the IO platforms are on Ethernet IP. This is phased migration. Next slide, please. So in addition to phase migration and the examples that I just ran through, you can also do bridging. So what is bridging and where would you do it? Well, when you're talking about water and wastewater protocols, you're probably talking about DNP3. And if there's a SLIC in there, then you may have DH45, you probably have DF1, who knows, right? Control net, device net, any of this stuff. Next slide, please. So bridging looks like this. Here you see two separate isolated systems, the old one on the bottom, the new one on the top. Both systems are running, but the old one is isolated. You can extend the life of that old functioning asset by bridging. Right? You're not modernizing anything. You're adding connectivity to a network that wasn't connected in the first place. Now you have access to it and to its data. Next slide, please. So everything I've shown you so far was basically migrating from old Rockwell to new Rockwell. You could do the same with legacy non-Rockwell systems. Looking at the list here, you can migrate from these non-Rockwell platforms to current Rockwell. I'll show you one example here with, let's say, SCADA-PAC. The next slide, please. So if you're competing against a SCADA-PAC RTU or you're upgrading from an older SCADA-PAC RTU, odds are you're going to need DNP3 in the new RTU. So here you see you have some options. The MicroLogix 1400 has native DNP3, but the DNP3 router, which Vishal showed in his very last slide, could be added to a Micro 800 or a Compact Logix platform to give them DNP3 compatibility. So I hope I'm not boring you with all these examples. I just have one more. Next slide, please. Okay, so you can't talk about water without somebody bringing up DF1 and leased line modems, right? And of course, Rockwell discontinued the 1761 net ENI, so what do? Well, again, you could do a phase migration here as well, and here's an example. Next slide. So the current architecture may look something like this. You see you have serial RTUs out there in the field connected to a central SCADA by way of lease line modems. So to initiate a phase migration, you might do the following. First, we'll get rid of the 3 RTUs on the bottom. Right? So you see here in phase 1, we've eliminated the serial RTUs and replaced them with compact logics. And then we added a DF1 gateway between the new PLC and the old lease line modem, which is still in use. So next, what we would do is, let's say, upgrade the SCADA shown at the top of the image. Now in phase 2, we've upgraded the SCADA to Ethernet IP and added another DF1 gateway between the SCADA and the existing lease line network infrastructure, which again is still on DF1. Then in our last step, we'll now replace the lease line modems one by one. So finally here you see, if you look at the site on the right, you see that the lease line modem to that site has been replaced with some form of wireless, as Vishal has been describing earlier, either an 802.11 radio or something cellular with PDN. So that's really the end as far as my talk goes on modernization and as how it pertains to water and wastewater. I'd say, the key takeaway here is this. Don't let the utility be discouraged and delay action on modernizing, their water infrastructure because of the daunting task of a rip and replace. You can do a phase migration to extend the life of some assets, and ease the risk. In the end, you'll end up modernizing everything anyway. But if there is hesitation to get things started, consider executing the modernization in stages. Thanks, Vishal.
Thank you, Vic. Okay, so just quickly in summary, we know that, like I said, both, the water wastewater industry faces some unique challenges, certainly around connectivity, and that's where you're here to help. You've got different types of connectivity. You sort of got your plant flow connectivity, where you're talking really different languages with different assets, and how to integrate all of that into sort of one type of common end, like a DNP3 protocol that not only gives you that commonality, but also ensures that you don't have any holes in your data, and then bringing that up to the top end. The remote connectivity is the most critical part of it, where because the assets are so geographically dispersed, and in that you've got a couple of different types. You've got sort of the plant connectivity, primarily within a treatment plant, where you don't need the cellular wireless. You can do that through 802.11, but then when you've got remote assets that are more widespread, you can connect to them through this readily available infrastructure that gives you this reliable, always on and always secure connectivity, bringing all of the information. And the key to remember there is the defense in depth that ensures that security is continuous, and you're able to not only have this always on and secure network, but also integrated through to your IT systems to ensure that they can monitor it as well. And then finally, you saw through Vic's section how modernization can really help you maximize life of your assets, give you that connectivity between the old and the new, and ensure that you can reduce your unplanned downtime as well. Okay. So this is my cheat slide and sort of why ProSoft. Our solutions are there really to help you not only just connect, but also to translate and to deliver the data from your source all the way through to SCADA. The products and solutions from ProSoft focus on diagnostics and security. Again, communications and is something that is a little bit more of a black magic in that you cannot see the wireless signal. So having this diagnostic capability is something that's very important to really understand what's happening. And of course, if you look at the support, whether it's from ProSoft or the system or our ecosystem of distributors and integrators, I think we're all very well known for that. So you'll understand that how easily and quickly you can get the support when you need to ensure that your downtime is minimized. Okay. So with that being said, thank you all for your time. I know we've sort of run almost to the end, but if there are any questions, we've certainly got a few minutes to go through them.
Yeah, I've got a few rolling in. First one I have, are there any Schneider phase migration hardware?
Sorry, can you repeat that again, Julie, please?
Yeah, sorry about that. Are there any Schneider phase migration hardware?
Vic, is that something that you can answer?
Schneider specific? I mean, yes. So, I mean, we do have some. We have a gateway similar to what I showed, where I gave the example there. You saw the drive and the panel view and the I/O being migrated from the PLC5. We have a version of that that's specific to. I'm trying to remember the name of the controller. We have one.
Of the Schneider M40?
I don't remember.
Okay. All right. There's another question that's come in. Julie, I don't know if you saw this. It says how to connect the MQTT broker. So the MQTT is available on our LDM, which is the Linux development module. You can connect to any broker. There are a couple of free ones, like Mosquito is a free one, but you would be able to connect to any MQTT broker with our LTM module, giving you that access where you can publish and subscribe the data.
Nice.
There's another question here which says, when remote RTU use DNP3 gateway, how FTView SE connect to the DNP3 gateway? Good question. So we assume that the FTView View SE can support DNP. It should be able to connect directly to the DNP3 gateways. But typically, if that's not the case, there may be a master PLC, for example, that's connected to the FTView. And that might be via Ethernet IP, but you could have a master, a DNP3 master gateway that's communicating to the slaves, where the data is then sent up to the slave PLC. The disadvantage in doing something like that is you would lose what DNP3 can do for you in terms of the timestamping. So it would be more advisable when you're using FTView, for example, to use a top-end Ethernet IP to DNP3 type converter that can get all of the data in via DNP3 and then sends it up to the top end.
Very good. Did you see this question over here on the Q&A box? With cybersecurity vulnerabilities popping up in water wastewater plants across the country more frequently, how could a solution from ProSoft play into combating these bad faith actors? That's a good question.
That's a very good question. Obviously, it really depends. I mean, there are so many variables when you're dealing with security. So in this case, this is very specific to the water wastewater treatment plants. Again, if it is simply connecting to the different parts of the treatment plant and bringing it in, if it is being done through the ProSoft Connect, like I said, that's an always-on communications network service, cloud-based infrastructure service, where the service itself is regularly pen tested. And then you have the defense in depth part of it, where you've got things like single sign-on. So, anybody cannot log on to the system. They could need a corporate ID. You could have multi-factor authentication enabled. And then the data itself is fully encrypted end-to-end between the different remote sites coming in. So defense in depth is sort of an overarching principle. You really need to look at the details as to how many levels, and we look all the way from the device through to the data. So we would need to look at how the connection happens, and then how we can help you ensure that it is fully secure.
Okay, there's a few PDU questions. If I'm using the PDU, do I need the DNP3 module as well?
So I'm not exactly sure what a PDU stands for.
They're also asking about time stamping with that.
With PDU only. So I'm assuming that the PDU means that it is a PLC or some kind of a controller. If that's the case, then the DNP3 module will be the one that's actually communicating to the PDU, getting the data, and then creating the date and time stamp for that data, which is then stored in the DNP3 module. and it'll be the DNP3 module that's connected to the top end, where you can then get not just the real-time information, but also all of the time-stamped information. And the time-stamping is one that happens at the source. So DNP3 protocol natively supports time synchronization. There's a command-specific command for that, so you can send that up. The gateway would be synced, and then, like I said, once it pulls the PDU or the PLC, gets the data, it would create the timestamp if the conditions are correct, and then that timestamp can be made available to the top end through different classes.
Okay, yeah, I think the clarification might be PLC here. Okay, we are at 36 after the hour, so we should probably wrap it up. But thank you so much for all your questions, everyone. And we will be sharing the presentation with you along with a copy of the recording so you can review. And I want to thank Vic and Vishal as well. That was great information, you guys.
Thank you, Julie. Thank you, everyone, for attending. We really appreciate it.
Thank you.
Thank you.